Hmm. So, hello everyone. My name is Rishi Karthik, and I am a student of IIT Roorkee. I am currently in my first year, and my branch is Data Science and Artificial Intelligence. So, today I'll be writing a program in C++ on how to create a simple, basic minesweeper game, and I'll be using only um, basic concepts in C++ such as for loops, if-else statements, and vectors, and I have added some features as well, which meaning the user can choose his own difficulty level, and the mines will be placed randomly, and all the number of mines surrounding any cell would be counted using for loops as well. So now the question is, what exactly is Minesweeper? And it is a classical puzzle game. So there's a square board or a rectangular board at sometimes, which has hidden mines, and the user must try to avoid all of them. And by mistake, if he clicks on any mine which is a bomb, then he just loses the game. And if he clicks a cell which is not a bomb, then the he will understand, or that cell will display the number of mines which are surrounding that cell. So it is more based on logic. So for example, I can show you a basic sample minefield. So for example, this is a minefield where this one here signifies that there's one bomb which is in the immediate neighborhood of this one, and that bomb is here. So this bomb is this symbol. It's a mine, and if when you click on it, you lose. So here this three means that out of these one, two, three, 4, 5, 6, 7, 8. So out of these 8 cells, there are three bombs. So it means that this is a high risk zone, and we should not click any cells here unnecessarily. So this is how we use logic to play this game. And moving forward, we have so now this is a basic Minesweeper game which I found online, and I've played it. I just played it, so you can watch it first. So if we notice here, so first as soon as I click any one button, there are a number of quite a lot of cells just expose themselves, showing the number of mines surrounding them. So now, for example, I've played here, which is a random point, but at least it is far from the. So, for example, let's take this point. So, this has three mines surrounding them, which must be this, because all the other points surrounding that are not mines, which is given here. So, obviously, we're not supposed to choose anything in this vicinity. So, due to that, I've just chosen a random point here, after which I know now. So again, after I choose this, I know there are three bombs surrounding this. So again, I cannot choose anything here because it's risky for the time being. So and then I choose another random point. So this is a yes. So there's only one surrounding it. So I thought it was a reasonably a safer place. So due to that, I just clicked a random thing surrounding it, but it turned out to be the bomb. So yes, the game ends. So this is exactly how Minesweeper works, and it is more like it's logical, but at sometimes it's more of it depends on luck. So let's see another one. So this is the easier version of the previous game, which was of medium. So this is easy comparatively, as you can see. So yes, so you could see that it was comparatively easier to get to the closing stages in this, because here a lot of the grids were already shown to us, and it is only a, what is it, it's like just a 10 cross 10, so obviously it becomes easier to traverse through it. And after getting some points, it is just easy that 2 2 2 2 2, so it's just that this region becomes a little dangerous. So I choose start choosing points here, and yes, I was very close to completing this level. So that's exactly the difference, which the choosing the level of difficulty, that's the difference it could make. And moving forward, so now we have seen the game, and so now we have a gist of how the game works. So now we have to write the whole the game in code. So I've just divided the structure of the code. So first we will be choosing a difficulty level such as easy, medium, and the difference was visible in the previously shown example. So and then after that we'll just randomly assign some mines. So and then again for each mine, for example, there's a mine here. So I'll be for this the cell right above that, I'll be calculating how many mines around that, for example. So I'll be doing that. And after that I'll just print the minefield, and then the user will just input. He'll just say, for example, the fifth row and the third column. So and then I will just if that cell is a mine, then obviously he will lose. So after that the game will finish, and then the original minefield will be displayed, and if not, then the game will continue till he either wins or he clicks a mine. So the first step, choosing the difficulty level. So it is a basic code here. I've just um, see out. So and then this I've defined a variable level, which I take the input. The user will just give it as an input. So yes, so if the level is 1, for example, it is easy version, which is a grid size of 6 cross 6, 5 with 5 mines in total. So out of 36 cells, there will be 5 mines, and similarly for level 2 and level 3. And in case the level is not 1, 2, or 3, if the user inputs 5, for example, then it is taken in this case, and in that case, invalid input will be displayed. So going forward, we have so, and then I'm just randomly assigning mines here. So I've taken the level 2, for example, which is a 12 cross 12. I've initialized the number of rows. So for example, so here I've taken a vector, a nested vector, for example, here to store the values. So the number of rows in it would be 12 and columns would be 12, and the total mines are 15. So here I've just taken any random 15 values, and then I've initialized them as mines, and the mines will be represented with the number -1 for simplicity. So, so now I want to calculate how many mines are surrounding each cell which is not a mine. So for this we'll need to use nested for loops. So here first we will be traversing through the row, and then for each row we will be checking each element. So this is a for loop where there we define an we initialize a variable r with the value 0, and then it will increase till it is, let's say, rows -1, and then plus plus r or r plus plus, whatever it is. And similarly for columns, so initially if we see r is 0, c is 0, and then we just check if that current cell is -1, meaning we just initialized the mines with -1. So if this cell is a mine itself, we are not supposed to calculate how many mines surround it. So in that case, we just click on continue, which will skip this current iteration, and it will go to the next step where C becomes 1, for example. And if it is not, then we define the of a new variable int mine count, which is initialized with 0, obviously, because we are going to calculate how many mines surround it. So now we define more variables, dr and dc. Dr is for traversing through the rows and dc for traversing through the columns. And for example, now this all of this is taken with respect to the one cell which about which we are calculating. So if dr, so every so a random cell could be represented as r plus dr and c plus dc would be the coordinates, because let's assume r is here, r comma c is here, so r comma c plus 1 would be here and r comma c minus 1 would be here. So similarly we would have 8 neighbors for this. But for example, if dr is 0 and dc is 0, which means the cell it is pointing to is the cell itself, then we will be skipping it. And now there's another case which we have to consider also, which is to check if the neighboring element is inside the minefield or not, because which I will show in the next slide. So here, for example, if r plus dr is greater than equal to 0, because for example, if let's assume it is less than 0, but the vector with the index minus 1 does not exist, because it starts from 0 and it goes to rows minus 1. So that means r plus dr must be greater than or equal to 0, and similarly it must be less than rows, because for example, if it is rows or rows plus 1, then in that case again it would go out of the minefield, which is not what we desire. So similarly we do that for columns as well. And then so this is just ensuring that that element for which we are checking is inside the minefield. And then if that point is a mine, then we will obviously include, so and then we go on adding it. So if the first element for which we check it is inside this and it's a mine, then the mine count is incremented by 1, so it becomes 1, and then so on and so forth. It goes on for 8, it runs for 8 times. And then after that, after we get how many mines are surrounding that cell, we initialize the minefield. For this is mine count. So this is a minefield which stores all the positions of the mines, and for the non-mine cells it will store the number of elements, still store the number of mines surrounding it. So that will be initialized with mine count, which we have just counted here. Now for example here, let's see. So this is what I was saying. So if this is a random element rc, this is rows columns, so this would be r because it's in the same row, and column plus 1. So this is how similarly this works. So for example, let's assume this is the first column itself, then this wouldn't exist. So it has only 5 neighbors in this case, in that case. So if we then search for these 3 elements, it would go out of bounds and it would give us an error. So due to that, we just check if it's in the boundary or not. So I think this clears things up. And now going forward, we have, and after that we have found the board, and now we need to show we need to start the game. So we need to, so we again display board, we initialize another what, it's another vector, multi-dimensional vector. So its name is display board because it will be displayed, and again rows columns, and initially we initialize all the elements of the display board as a hash button here. And first we decide to reveal only 2 cells, and again it's completely random, I've just chosen these 2. And here the problem is, as this minefield is contains an integer value, because it was either containing -1 or the number of mines surrounding it. So here this is effectively typecasting it to a character. So because here we need a character because I'm using hash, so I have to use a character. So I've just typecasted it. So now this integer becomes a character, and so now and then I'm storing it in the display board to random. And then for this is another variable I've defined, which shows the number of cells which are being revealed. So first, obviously, we'll have to reveal some cells at least. So I'm taking two, for example. So this is the first. I'll display the current state of the display board. So int r. So again, for the rows, initially first it will be 0, 1, and till rows minus 1. Similarly here, and then so first it would be r would be 0, c would be 0, so display board 0, 0, the left topmost element, and after that c plus 1, and then this would be separated by a space here. So like that, this whole row would get printed, and after that, after this for loop is completed once, then r becomes 1. No, I mean this for loop is just gets completed. This runs for once. After that, r becomes 1. So after that, the second row gets printed. So like that, we get the whole display board again. So again, we're just prompting the user. Now the user will enter the row and the column which she will choose by logic or luck, whatever. But the one thing to notice is that this is a zero-based index, meaning that it is assuming there are 10 columns. So the columns wouldn't be named as 1, 2, 3, 4, 5, 6, and so on. It would be 0, 1, 2, 3, 4. So it starts from 0. So that is what zero-based index signifies. And we are just taking it as an input, rows and columns. So again, we are checking if it's inside the minefield. If row is less than 0, then obviously it is invalid. So in those cases, we are just giving it as invalid coordinates and continue, meaning that this it would go to this step again. So again, the user will input the rows or column, and again it would check if it is inside the minefield or not. So assuming it is inside the minefield, and now we check if that is a mine or not. So here we are just checking if it's a mine because they are initialized with -1, and here we are checking minefield, not the display board, because the display board is initialized with hashes. So if the minefield of that element is -1, then obviously is it a mine? So boom, he hit a mine, game over. And there's a break statement, meaning this infinite loop would get exited at once, and the game is over. But assuming this does not run, meaning that it is not a mine as well. So he has clicked an element which is not a mine. So in that case, so that display board, which is initially represented by a hash, would be initialized by the number of mines surrounding it. Row column equals to minefield row column plus 0, typecasting again. And the revealed cells would be plus plus because initially it was 2, and now he has clicked on another cell which is not a mine. So that 2 becomes a 3 for example. And then we are checking if he has won the game or not yet, because when will he win the game? When all the cells which are not mines have been revealed. So that is when, so rows into columns gives the total number of cells in that minefield minus mines. So this will give us the total number of possible legal entries a person can make without losing. So if that equals the number of revealed cells, then he has cleared the minefield, and in that case also there will be break statement because he has won the game obviously. So this is how we take the input, and this is pretty obvious. If he clicks on a mine, it's when the game's over, and when all the non-mine cells are revealed, the player wins. So after that, yes. So after this game ends, either by winning or losing, does not matter. So after that, we will print the original board, which is the minefield. So this will show where the mines are and how many mines surrounding each cell, everything. So again, it's the same thing. R equals 0, R less than rows, R plus plus or plus plus R. We are just displaying it because here it's the minefield, it's not the display board. So yeah, the original minefield is displayed with all the mines and numbers. So yes, this is the whole code in total. So if we see first, we're just including the default packages such as iostream and vector because we are using the multi-dimensional vector. After that, it's we're defining a function void game which is taking an input level as a parameter. So if level is 1, obviously row 6, column 6, mines 5, and randomly 5 mines. Similarly for 2 and 3, we're just randomly assigning mines, and the number of rows are given here 18, 18, 50 for level 3. And after that, here we are calculating the surrounding mines by first checking if the cell is a mine itself. We are skipping it, and then after that we are just checking the boundary conditions. And again, if we have a mine, the variable for calculating the number of mines is incremented by 1, and then we create the new display board. We initialize it. It's another multi-dimensional vector initialized by hashes first. So yes, it's again the same thing, taking user inputs one by one, checking if he's winning or losing, and after the game ends, the original board is printed. So after that, I'll just now we'll have a live demo. I will run my code once, and you can see how my code works exactly, and you will understand how it is different from the online game which we played earlier. So this is the code in Visual Studio Community, and I have left lines and added comments for better readability. So main game function, setting up the board, it's the same thing as I've explained earlier. For level 1, level 2, level 3 specifically, random mines and such, initializing, and then this is the important part, calculating surrounding mines for each non-mine cell. If minefield is it's a mine itself, then we continue. If not, boundary conditions, we're skipping the current cell itself and then checking if it's a mine and then incrementing by 1, so on and so forth. And then typecasting here, and then there's a while true loop for running forever. It'll There'll be a break statement only if he clicks on a mine or if he has cleared the minefield. And this is the main function here. So I'll be running this code twice now, once for a hard version and once for a easy version to see how it goes. So let's do the hard version first. So I've got the prompt from the user. Welcome to Minesweeper. Select the level of difficulty. As you want to play hard, it is level 3. So we'll enter 3. So we get this grid 18 cross 18 with 50 mines as decided earlier. So again, it's a zero based index, so we have to be careful and not enter any invalid coordinates unnecessarily. And if we do enter invalid coordinates like this, we get invalid coordinates and nothing changes as such. So now let's just play randomly. 2 3 2 6. So we have not hit any mine yet, and most of the cells we just clicked are having 2 mines surrounding them. So there's nothing to do logically till now, so just playing randomly. So now when we click on 413, so there was a mine there, and due to which we lose now the original board. So as the game is now over, the original board has been printed right now. So this is the original board in the minefield. So the program ends and the game is functioning as we can see. So now let's try the easy version. So for that we'll be entering the level of difficulty as 1. The grid size is 6 cross 6 with 5 mines. And again we'll be entering any rows and columns. So 2, 4, and then 1. So this again. So here if we see there's no mine surrounding it, so I can enter all of these 3 elements now. again doing similarly. So now using logic, I've just opened all of these cells because there were no cells surrounding it, no bombs mines surrounding it. So continuing now, 4 and 4 for example. So now this is the difference. Now I've hit a mine and I've lost. And this is the difference if we see that it is way more logical. It is more dependent on logic in such easier or smaller grids. And as for the program, it's a functioning version. And the only difference is that if I play this game twice, the mines will still be at the same place, but in the online version, they will keep on changing randomly. And other than that, it's pretty much the same thing. So this was the function of the project to create a um, game of Minesweeper which is working using C++, and that is done. So thank you.